Hey Carly, here's a couple more examples of writing in explicit and recursive form. This is an arithmetic sequence. So first I want to identify the common difference. To go from 3 to 9 is plus 6, 9 to 15 is plus 6, 15 to 21 of course is plus 6. So once we know that common difference, I can identify the recursive form pretty easily. I need the original amount, which is, let's call it f sub 1. That means the value of the function for the first term, this is the first term, second term, third term, fourth term, is going to be 3. And I get that from my actual sequence. And then I want to identify the function. And if we're thinking about this recursively, all I need is the previous term and the common difference to find the next term. So in this case, the common difference is plus 6. So we're adding 6 to the previous term. And the way we identify the previous term is using the f of x minus 1. If f of x, if we want to find the term that's prior to x, then we need to subtract 1. We need to go back 1. For instance, if I want to find f of 3, then I take the value of f of 2, which is the previous term, and add 6 to it. And that will give me the value of f of 3. So this is my recursive form. Okay. Explicitly, I want to think about how these term numbers are related to the actual values of the terms, values. So how is 1 related to 3, 2 to 9, 3 to 15, and 4 to 21, and so forth. So one way we can do that is by writing this in this form, f of x equals f of 1, which is the first term, plus the common difference times x minus 1. Okay, the original amount is 3, the common difference is 6, and it's always going to be x minus 1. Okay, this means I'm adding groups of 6 to 3. How many groups of 6 am I adding? I'm adding one less group than it is term number. So again, if I want to find f of 3, I will take x minus 1, which will be, if x is 3, then x minus 1 will be 2. Then I want 2 groups of 6. That's 12, plus 3 would make 15. Now, what I could do is simplify this a little further and distribute this 6. That gives me 6x minus 6. And then I can combine my like terms and ultimately end up with f of x equals 6x minus 3. That will be my explicit form. Likewise, over here, identify that common difference. Recursively, my first term is 7. Okay, and I want to write a recursive form. I just need to find my common difference, and I'm adding the 5 to the previous term. The previous term is always going to be identified as f of x minus 1 or f of n minus 1, either way. That's what this is saying. We're adding 4 to the previous term. That's thinking recursively. Explicitly, if I want to use my explicit form, x of 1 plus d, the common difference, times x minus 1. The common difference, x sub 1 is 5. I'm adding groups of, x sub 1 is 7. The original amount is 7, and I'm adding groups of 5, the common difference. How many groups of 5? X minus 1 groups of 5. So if I want to distribute this, it's going to be 5x minus 5. Combine my like terms, give me 5x plus 2. f of x equals 5x plus 2. I can check that out. 2 times, this is my first term, second term, third term, fourth term. Let's say I want to find f of 3. f of 3 would be when x is 3, so it's going to be 5 times 3 plus 2, which indeed would equal 17. Just to check it out a little bit. Oops.